Now we will see how we can go for assembling the created parts or the modeled parts of the Cotter joint assembly. So in order to do that, first we go to the SolidWorks, we go and click on this new. There we are going to use assembly, and then I will click on OK. Now it's the time to bring the created parts to the assembly layout here. Okay, we have to import the assembly parts to this we have to import the modeled parts to this assembly layout. In order to bring them, okay, so you can go to click on browse option here. So go to the browse and select the first part. Okay, is that clear? So select the first part, that is socket, and I need to place this socket exactly at the origin of the assembly layout. In order to do that, I will take the cursor onto this feature manager design tree tab. Okay, tab here. Once you click on that, this particular assembly tree will appear here. Then expand that. Then click on this origin. Okay, so then the origin of the socket part is going to coincide with the origin of the assembly layout. Once it is done, it's the time for bringing the next component. So go for insert components again, go to browse. So try to pick the spigot part now. Okay, and place the spigot part somewhere closer to the socket part. Okay, so now what I do is we want to insert this spigot inside this hollow portion of the socket. In order to do that, first we are going to establish we are going to make the axis of this spigot collinear with the axis of the socket. In order to do that, we have to use the concentric option. In order to use the concentric option, I will go for clicking on the mate here. Okay, mate command. Then I am going to select the inner surface of the socket. Okay, and the outer surface of the spigot. Once these two faces are selected, okay, by default the software will take the concentric mating option. Then click on OK. Now, okay, if you try to keep it in front view, so this particular spigot cannot be moved up or down. Only freedom, linear motion available now is it can be moved to left or right. Okay, and about its own axis it can be rotated. You can see here. Okay, so it has 2 degrees of freedom. So what I do now is, so first I am going to restrict its rotation motion. So in order to restrict its rotation motion, okay, what I do now is, so I am going to select this particular plane here, vertical plane will be selected, and I am going to select this vertical plane appearing here. Once these two faces are selected, okay, so it has taken the coincident option, or if you want to use parallel option, you can use. Select that. Once those two planes are made as coincident, okay, now only option available, only freedom available with the spigot is it can be moved to the left or right. Okay, but when we try to move towards the left here, okay, so what happens is this particular left face of the collar will come in contact with the right face of the the right face of this socket end. So therefore, when what you have to do is when mate option is on, go for selecting this left face of the collar and the right face of the socket and click on OK. Once it is done, okay, the spigot is completely fitted into the hollow portion of the socket. Now you can check the isometric view. So this is going to be the top view and this will be the front view. Okay, so again let me keep it in isometric view now. So then what I do is, so it's the time for bringing the next component, that is the last component of the Cotter joint assembly, that is Cotter itself. So try to select the Cotter and place it somewhere here. Okay, so then what I do is I need to align this Cotter with the Cotter hole first. So let me check where is the front plane. So this is my front plane, and when I have brought the Cotter, so for the Cotter part, where is the front plane? This is the front plane. So this is the front plane. Okay, so this is the front plane of the Cotter part, while this is the front plane of the entire assembly, or you can also select the front plane of the socket. Okay, you can see here this is the front plane of the socket. Okay, because we have assembled the socket and the spigot such a way that the front plane of the socket and spigot are coinciding with the front plane of the entire assembly. So therefore what I will do now is, okay, but my front plane of the my front plane of the Cotter is somewhere else. So front plane of the Cotter is here, while the front plane of the entire assembly is here. So therefore what I do now is I will go for selecting mate option, then I will select the front plane of the assembly, and then I will select the front plane of the Cotter part. So front plane of the Cotter. Then okay, these two planes will become coincident. Okay, you can see, so these two planes are parallel now and coincident. Okay, now if you try to check it in the top view, when you try to move this cutter up or down, it will not move. Only freedom now it is having is it can be moved left or right. Okay, is that clear? So, and when you see it from the front, it can move. It can be moved at, okay, top or bottom. Okay, it can move up and down now. Okay, in the front view. Is that clear? So, if I want to restrict the which one, if I want to restrict the even up and down motion, then what I have to do? So, I am going to check where is my top plane. So, this is the top plane of the assembly. So, let me keep it in isometric view. So, this is the top plane of the entire assembly, and this is the top plane, okay, of the which one? Cutter. And I have made, so I have selected the top plane of the entire assembly and the top plane of the part 3, that is the cutter. Okay, you can see here. Okay, top plane of the part 3, cutter 1. Okay, so now these two planes have been made as coincident. Okay, so once these two are made as coincident, you can see it cannot be moved up or down. Okay, if you try to keep it in front view, so it cannot be moved up or down, and if you keep it in top view, it cannot be moved up or down. Okay, means there will be no sideways movement, okay, in the top view, and there will be no vertical movements in the front view. Only movement now it is having is, okay, left to right, that is horizontal movement it can have. So what I do now is, so as it can be seen here, okay, this is the tapered side, this is the straight side of the cutter. Okay, so I am going to bring this particular face. So I am going to select this, I think point I selected, delete this. Okay, so this particular face should make contact with this particular face here. Okay, so then keep it in isometric view. You can see here. Okay, so the cutter has been put inside the which one cutter hole now. Click on OK. Okay, so close the mating command and try to keep it in isometric view. Okay, so now you can see, even if you try to move this cutter, it will not, you cannot move because it is completely constrained now. So all the three parts of the Cotter joint assembly have been constrained with respect to each other. Means the part 2, that is spigot cannot move with respect to the socket, and cutter cannot move with respect to the spigot as well as with respect to the socket. Means all the three individual parts are constrained with respect to each other. Okay, that's why, okay, the assembly is fully constrained now. So let me save this file now. So I am going to save this as assembly 1. Thus it is Cotter joint. Okay, so therefore the assembling of the individual parts is completed now. Okay, so we will move on to getting the orthographic views for this assembled Cotter joint. So how it can be done, I will explain now. So first close this assembly layout. Now go and click on the new. Okay, now, okay, so first we created the individual parts of the Cotter joint, then we assembled them together by using assembly option. Now we are going to use the drawing option. So I will use this drawing option now, then click on OK. Okay, so in the beginning it will ask what kind of sheet we want to use. So we use A4 sheet. Okay, for because for taking printouts and all, A4 size sheet will be better. Okay, so therefore I will use A4 sheet, but whether the sheet should be in the portrait manner or in the landscape manner, that should be selected. For doing that, I will go to the browse here, and I will come and choose. Okay, so A4, because right now the A4 sheet is in portrait mode. I want to rotate that to the landscape mode. So in order to do that, I will go and click on the browse there. Okay, and I will try to select A4 landscape. Okay, this will be selected, then click on OK. Once this is done, we can see we have got the A4 sheet with landscape orientation. Then here, okay, on the left side, you will be asked to browse for the assembly or the individual part for which we have to get the orthographic views. So this is the model view, but don't use this model view right now. Close this one, then go and click on the right click on the sheet one. Okay, so close the model view, then right click on the sheet 1 appearing on the left side, then click on properties. Okay, here first thing that you have to do is, okay, you have to change the type of projection to first angle projection, because in India, okay, we are going to follow the first angle projection. That is, we assume that the object is going to be between the observer and the reference plane. Okay, and always the front view will be above the top view, or the top view will be below the front view. Okay, so therefore first angle projection should be used. So select that. Okay, is that clear? So first angle type of projection should be changed. How it can be done, how it has to be done? So right click on the sheet 1, go to properties, here change the type of projection to first angle projection. Once it is done, now you go to view layout command tab here. Okay, then click on model view. Okay, then when you click on model view, again it will ask for which part or for which assembly you want to get the orthographic views. Means it will ask for us to open the part file or the assembly file. Now I will go and click on the browse here. Okay, so I will select this assembly one, Cotter Joint. So now right now there is only one rectangular box appearing here. This is the indication of software is trying to give us only one view. Okay, so which is that one default view that can be seen here on the left side. So it is trying to give us only the front view, but I want the front view, top view, side view, as well as the isometric view. In order to get them, what I do now is, so on the left side, okay, I am going to turn on create multiple views. So I am going to turn on creating multiple views. Okay, once it is done, so by default always software gives the front view, but in addition to that I need top view now. Select that. Then I need the isometric view. Select that. We need the side view, that is the right side view we require. Select that. Okay, so select all these three views now. Okay, plus which one? Isometric view. Then click on OK. Is that clear? So click on OK. So and now this is the front view, this is the top view, this is the side view. So you can drag. So when you try to drag the front view, okay, so automatically the side view and the top view will be adjusted, because front view, top view and the side view all will be aligned with respect to each other. But we can move this isometric view to anywhere we want, somewhere here. Okay, so I am going to drag it to somewhere here. This is the isometric view. Okay, so therefore this is the which one? These are the, so these three are the orthographic views of this Cotter Joint assembly. So then what you can do is you can go for saving this file as the drawing file. So assembly one Cotter Joint, it will be saved as a .drw file. Save it. Once it is saved, okay, so you can also go for inserting the bill of materials. So for doing that, go to insert. Okay, on the top and go to tables, go to bill of materials. Okay, so here it will ask select a drawing view to specify the model for creating bill of materials. I am going to select this. I am going to click on this isometric view. Then it will ask top level only. Okay, so how we have to list the parts. So I will go for top level only. Okay, then I will click here and I will click on OK. And now you can see the bill of material is appearing here. And since we have not added any description for our part files, okay, so description column is empty here. So I'm going to right click on that description column and I'm going to delete that particular column. Now in this particular bill of materials now, okay, you can see here. Okay, so it is showing there are three columns. First column is item number, that is part number. Then we have, okay, part number, okay, names of the part or item. Item 1 as socket, item 2 as spigot, and item 3 as cotter. Okay, and all these have been used only one in quantity in our assembly. Okay, so only one quantity of socket, one quantity of spigot, and one quantity of cotter has been used for creating this assembly. Okay, so this is all with respect to generating the orthographic views of the Cotter Joint assembly. Suppose if you want to show some hidden edges in this which one front view, then what you have to do is you have to right click on this front view. Okay, you should go to the properties. Okay, and here you should go for clicking on show hidden edges. So which edges should be shown? So edges corresponding to this Cotter should be shown. Then click on apply. Okay, so now you can see the hidden edges are visible. Similarly, if you want to see some hidden edges related to the spigot or the socket, then click on this area here, go to the properties. Okay, so then show hidden edges. Okay, so here which part again? I want to show the hidden edges corresponding to the spigot now. So that spigot has been selected. Click on apply. Okay, so therefore, okay, you can see the hidden edges with respect to the spigot also here. Is that clear? So this is how you can go for showing the hidden edges in the front view, or in the same thing you can right click here if you want to show any hidden edges here. Go to properties and select the component for which hidden edges should be shown. Then select that and click on OK. You will get all the hidden edges of the hidden edges in the top view of the Cotter joint assembly. Similarly, for side view also you can do it. Okay, so here suppose if you want to show the hidden edges related to the Cotter here, so then right click here. So right click properties. Okay, so then what I do is show hidden edges of the which one? Cotter. Okay, so Cotter part has been selected. Apply. Okay, so now you can see hidden edges of the Cotter is appearing here. Okay, so this is how you can go for showing the hidden edges in different views. Okay, so this completes the assembling of Cotter joint. Thank you.